Right, so the last section we're going to take a look at is 11.3, and it's on the binomial theorem. So basically what the binomial theorem is going to do, just to kind of show you the end result here, it's going to allow us to take something like this and do it out pretty quickly without having to write 2x plus 3y 12 times and then FOIL all of them together. All right, that's basically what it does. All right, so let's look at some patterns here. So I've done out like a plus b squared. This one's not that bad, right? It's just a plus b times a plus b, and that's what you get when you FOIL it out. Now, I didn't put coefficients in front of a and b. I did in front of the ab term. But what's the coefficient in front of a squared? 1. And how about in front of b squared? 1. It's also a 1. Any question on that? The 1, 1. Now, if you take what I just had up above, which is a plus b squared, and multiply by a plus b again, and FOIL it out, you get that. And again, what coefficient is in front of the a cubed and the b cubed? Both 1s. And now after this, it would start to be really time-consuming to do out. But if you took what I have on the right side right here and multiplied by a plus b and distributed it all out, you would have like a to the 4th, you'd have a 3a cubed b, you'd have a 3a squared b squared, and that's what you're going to see right here. Right, so there's your a to the 4th. And you'd have some other terms you can combine too. You'd have some other like terms. Okay, you don't have to really keep writing them. I just want to kind of look at what's happening here and see a pattern. If you write it up to like the 4th one, that's really enough. So now we've got a 1 here and a 1 here. Does anybody notice patterns in what we've written here? There's a lot of patterns here to kind of describe what's happening. Patterns with exponents, there's patterns with other numbers, all kinds of stuff. Yeah?
So for the number in front of like the a and the b, it just keeps going up by 1. Like the a squared b is 3, and then the a cubed b is 4. You see what I mean?
So I see that this is a 3 and this is a 4.
Yeah, it's going up by 1.
So it goes up by 1?
Yeah, go down to the 5.
Oh, like 2, 3, 4, 5?
Yeah.
That looks awful. All right. Okay. So yeah, we definitely got something going on there. What else for patterns? Yeah.
Well, starting from like the outer edge of the equation, the exponents are higher, and then as you go towards the middle, they're lower by 1.
Yeah. So if you look at like the exponent on the a, it's a 5, 4, 3, 2, 1, and then it's gone. So the exponents on the a go down. How about the exponents on the b?
They
go up. First it's a 0, right? It's not even there. Then it's a 1, 2, 3, 4, 5. So the exponents on the a go down by 1. The exponents on the b go up by 1. Did anybody notice anything else? A couple important patterns we haven't noticed yet. Yeah?
all the 1s are on the outside.
Okay, you have 1s on the outside. 1, 1, 1, 1. Right? 1, 1, 1, 1. Does that remind you of anything? The Pascal's triangle. If you write out Pascal's triangle, the numbers in Pascal's triangle, which I'm going to come back to this, are coming from right here. 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. Those coefficients are the rows in Pascal's triangle. Let's see. We'll come back to that. One other pattern. when you square something like this, you square a binomial, how many terms do you get? So how many terms are right here? 3.
So it's always one more than that.
It's always one more than the exponent. So when I raise this to the 5th, there should be 6 terms there. 1, 2, 3, 4, 5, 6. So that's another pattern. Okay, I think we've pretty much mentioned all of them. So in each expression, there's n plus 1 terms, one more than the exponent. We just said that one. The sum, actually, I don't think anybody noticed that, but the sum of the exponents in each term is n. 4, 1 adds up to 5. 3, 2 adds up to 5. 2, 3 adds up to 5. 1 and 4 adds up to 5. The sum of the exponents in each term always add up to the power. This one we noticed. So the degree on A went down by 1 each time. Degree on B went up 1 each time. And the last one, which we looked at, where are the coefficients coming from? They're coming from Pascal's triangle. So knowing all these patterns, we should be able to expand a binomial to a power without having to really do any foiling. All we have to do is basically follow a pattern. And there's a few things to remember, like some exponents are going down, some exponents are going up, but this is the hardest one to deal with, where the coefficients are coming from. Okay, so let's like this. So if we look at Pascal's triangle, let's say I wanted you to do a plus b to the 20th. What would that require you to do? It would still follow all these patterns. But why would a plus b to the 20th be difficult? Even though you know all the patterns to look for. Something that would be hard, yeah.
You still have to write out all 21 numbers.
You still have to write what?
Oh, you still have to write out all numbers.
What numbers? Yeah?
One's in Pascal's triangle.
One's in Pascal's triangle. So if you wanted to do a plus b to the 20th, you're going to need a row in this triangle that's way down somewhere. How are you going to get that row? Well, I guess you could do it by hand, but in 20 is not that bad, but it's still going to take a really long time to do it. So the fact that these coefficients are from Pascal's triangle, good to notice, but there's a better way than Pascal's triangle. We'll talk about that. All right, so with this stuff, we got to kind of keep track of what's going on. Okay, so Pascal's triangle, the first row is row 0. So if you want to raise something to the second power, the coefficients come from the second row. If you want to raise something to the 5th power, the coefficients come from the 5th row. But you've got to make sure you count starting with 0. Okay. Any questions on that? So how does Pascal's triangle work? Like, where is this 15 coming from? Yeah?
5 plus 10.
Yeah, it's the sum of the two numbers that are above it. 1 plus 5 is 6, 4 plus 6 is 10, 3 plus 3 is 6. That's how you're getting your triangle. You always put 1s going down the outside edges. Okay, that's how that works. So each row begins and ends with a 1. Okay, every entry in the row is the sum of the two above it. And this is what I just told you. The numbers in the nth row are the coefficients when you expand out a binomial to the nth power. There's also a lot of symmetry in the triangle. The row kind of, like, look at row 6. 1, 6, 15, and then 15, 6, 1. So it's kind of repeats itself. So if you have a row with an odd amount of numbers in it, then there's a middle, like that. If you have a row with an even amount of numbers, then it's kind of like there's 2 in the middle. Right? 1, 5, 10, 10, 5, 1. So ultimately, the kind of thing I'm going to ask you to do is, I wouldn't ask you to expand out a plus b to like the 15th power. What I might say is, if you did out a plus b to the 15th power, tell me what the 10th term would be. Right? So you get a bunch of terms when you do it out. I just want to know one of them. So all you have to do is figure out one number from Pascal's triangle, not the entire 15th row. Just one number, okay? And then what should the exponents be? Well, we know the exponent should add to 15, so we just have to figure out, how we just kind of count, starting with a to the 15th, 14, 13, 12, count to whatever term we need to get to. Okay? But just the trickiest thing is going to be getting the number in this triangle. Okay, so let's do a plus b to the 6th. That's not that bad. We've got the triangle already done to 6 rows. So let's see what we can do. All right. So what's going to be my first coefficient? 1. Right, so we're working in this row right here. So we got 1. And then what about the power on A? A to the 6th. And what about the power on B?
6.
0. So the exponents on A are going to go down by 1. Exponents on B are going to go up by 1. But the first exponent on B is 0. It's not even there yet. Okay. Plus. What's going to be my next coefficient? 6. 6a to the 5th, b to the 1st, so we can just leave it as b. All right. The next term would be what? 15.
A to the 4th, b to the 2nd.
Yep. A to the 4th, b to the 2nd. And the next one? 20.
A to the 3rd,
A to the 3rd, b to the 3rd. And now we're going back down. So the coefficients have gotten as big as they're gonna. So now we're gonna have 15, a to the 2nd, b to the 4th. Then 6, ab to the 5th, and the last term, b to the 6th. You can put 1b to the 6th or just b to the 6th. So that's what you get when you expand that out, without having to FOIL it. Any questions on that idea? All right. So let's try this one. A little different, because this time, think of this whole thing as your A, and think of this as your B. So whenever we write A, we want to make sure we put it in parentheses. Okay. So row 4, let's copy that over. Row 4 is 1, 4, 6, 4, 1. Okay, so first coefficient is 1. And normally we put A to the whatever power. What's going to go in the parentheses right here? 2x to the what power? 4th. So 2x to the 4th, we have to do that out after. Okay. Plus, how about, Nate, what's my next coefficient?
It'd be 2x, or it'd be 6, no, not 6, we're on row 4. 4 in parentheses, 2x, and then A, 3, B, just B.
I like the 4 and the 2x. That's good.
Okay.
But this A3b, I'm not sure
Alright,
about that. But we'll have the 4 and the 2x, that's good. Yeah?
You cube the 2x,
Cube the 2x,
and then there's just a y.
and then just a y to the first. All right. Tori, how about my next term?
6.
Yep.
And then it's 2x. And then it
2x, and then another x on the outside?
2x to the second.
2x to the second.
And then y.
Y to the second. Yep. So 6, 2x squared, y squared. How about Kaya, my second to last term?
4 parentheses 2x, and then y to the third.
Yep, y to the third. And my last term, now the 2x term is gone, and the coefficient is a 1. So it's just 1y to the fourth, or just y to the fourth. Now, because this one had, basically within the binomial, the first term had 2 factors, 2 and an x, so we have to do that out. So remember, you raise each factor to the power. So 2 to the fourth gives me 16, and then x to the fourth is just x to the fourth, and I would multiply by the number in front after. But in this case, it's just times 1. Right. How about the next one? 2 cubed is times 4. So we get 32 x to the third y. All right. How about the next one? What's my coefficient going to be?
4.
Yep. 4 times 6 is 24. X squared, y squared. Next coefficient? So it's just 8 xy cubed. And the last one stays the same. So that's what you get. So a little bit more work because we had to do that extra step. But in a problem like that, I also would lower the power a little bit so it's not as high of a row in the triangle. Questions on that one? All right, let's try. Let's try one with a negative. Okay, even lower row in the triangle. Now it's only to the third. What's the third row in Pascal's triangle? Yeah. 1, 3, 3, 1. Okay. Don't try to do out the powers and deal with the negatives and, oh, is it a negative to an even or a negative to an odd power? I would just write it all out and then go back through it a second time. All right, so we're going to have a 1. And Natalie, what's going to be after that?
3x to the third.
3x to the third. All right, so there's that one. Ashley, my next coefficient?
3.
3. And then I'm going to have a 3x to the second. And another set of parentheses because now within this binomial, each term has 2 factors. So what's going to be in the second set of parentheses? Negative 2y. Okay, so 2 terms left. How about Gabe? What's my next coefficient?
It's going to be 3.
3.
Parentheses 3x. And then negative 2y squared.
Negative 2y squared. So notice here, each time these exponents add up to 3. That's a 3. 2 and a 1 gives me 3. 1 and a 2 gives me 3. And now what's my last term? Yeah, Ron.
1 parentheses negative 2y cubed.
Cubed. Okay, so now we've got a bunch of stuff we got to do out there just like last time. What's 1 times 3x cubed? 27 x cubed. All right. Anyone think they can tell me the coefficient that's going to go next?
27x squared minus 2y.
So I like the x squared, that's good, and the y. But what's the number going to be in front?
It's going to be 27 because you're times
Yeah.
9 times the 3 would be 27.
What about this negative 2? So this is all multiplied, right? This times this times this. So they all have to be multiplied. So we do get 3 squared is 9 times 3 is 27
So negative 54.
times negative 2. So it's really negative 54. It's the first time we've seen a minus come up in this formula. Whenever you have a minus in the middle of your binomial like that, it's going to alternate now. One term will be positive, the next term will be negative. Okay, so the next term will be positive. So what are the letters going to be in the next term?
X.
Yep, and y squared. So we get xy squared, and now we got to do all the numbers, but just do exponents first. Negative 2 to the second, 4 times 3, times 3 again,
So it's like 36.
36. Okay, so 36xy squared. And the last one, well, plus, minus, plus, minus. What's negative 2 cubed? Already got my negative right there. And we have to cube the y. Okay, so that's how you do that one. Any questions on that one? Okay, now, the last one, I don't think we need to do this out, but what's going to happen here is you're going to end up with something like this eventually. You're going to have a power raised to another power when you write this all out. What do you do with the exponents when you have a power to a power? You add them if you had something like this. This would be y to the fifth. But when it's a power to a power, you multiply them. Okay. So this situation is going to come up. Okay. Not with the x's, just with the y's. Any questions on how you would do that one though? Okay. So, if the power you're raising to is small, Pascal's triangle, pretty easy to use. If we start getting large, we need a better way. Okay. So, what we've been doing so far is taking binomials, remember, binomial means two terms, and raising it to a power. So when you do that, you get all these coefficients, like 27, 54, 36. Those numbers come from what we call binomial coefficients. So what we're going to look at now is what's called the binomial theorem. It gives us a way to figure out the coefficients, even if you had something like that. I wouldn't ask you to do something like that out, but I might say, what's the 35th term if you did it out? Just that one term. That's all I want to know. So let's see how we could figure that out. All right, to do that, it's going to involve what's called a factorial. Does anybody remember factorials? Okay, I'll show you what it is. So what we have here is it says basically for any positive integer n, the way we write, the way you pronounce it is n factorial. Or what you, if you wanted to read what's in parentheses here, it's the symbol n. So you say it because it's an exclamation point. You have to get excited. It's a rule. All right? So that's the symbol for a factorial. Put an exclamation point after the letter. Okay, so just read it like it's your birthday. All right. So for example, n equals the product of every number from 1 up to your number. So like 6 factorial means 1 times 2 times 3 times 4 times 5 times 6. That's what a factorial is. Product of every number from 1 up to your number. Now it seems kind of weird, but you can actually do it with decimals. Like, so how would you do that? Because factorial really, it only applies to integers. You multiply every integer from 1 up to your integer. But if you type in decimals for this on the calculator, it does work. We're not really going to get into it. I'll just show you one without a decimal first. So 5, I think it's under math, number, nope, it's under probability. So if you go to math and you go to probability, the exclamation point is the fourth one down. So this is going to give me 5 times 4 times 3 times 2. So let's just see what it would be. 5 times 4 is how much? 20 times 3? And then times 2. 120. So 5 factorial is 120. So if you type in like 4.5 factorial, you get some weird number. It has something to do with pi, I believe, but we don't really have to worry about decimal factorials. Okay. Just integers. Now, what do you notice about factorials? Like if I type in 7 factorial, to going from just 5 factorial to 7 factorial, what happens?
Intense.
Why is it intense?
It goes from like 120 to 5,000.
So just going up 2 numbers on, think of that as like the x value, the y value went up almost like 4,800 units or something. So factorials get very, very big very quickly. In fact, by the time I even type in like 15 factorial, it's already giving it to me in scientific notation. Okay, 1.3 times 10 to the 12. The calculator can't go that big with factorials. It can only go till this exponent hits 99. So if you try like 25 factorial, 25 is not that big, but our exponent is starting to get pretty big, so we're not going to be able to go too much more. I think by the time you even hit 100, the calculator can't do it anymore. So it's too much. So somewhere between 25 and 100 is where the factorials kind of cut off. This calculator, even though I don't really like it as much, I think it can do bigger factorials because it allows the exponent to go into the hundreds. So in scientific notation, graphing calculators don't let it go beyond 99. Right? But then if I hit factorial again, now it says invalid input. So eventually, I guess even this one, it gets too big. So, but it's not really about how big it's going to get, because even if you can't do it on a calculator, you can still do it by hand. And I'll show you some trick how we're going to do that. So 0 factorial, that one's kind of weird. You're multiplying every number from 1 up to 0. So that one, it's more of a definition. 0 factorial is defined to be 1. Now, what if you multiply every number from 1 up to 1? What would you get? 1. How about 2 factorial? 2. So far it doesn't look like it's really getting that big. 3 factorial? 6. And 4 factorial? 24. And then 5 factorial, we already did that one. That was 120. So it does start to get really big all of a sudden. So what we're going to use is factorials to find the numbers in Pascal's triangle. There's a connection between the two. So if you want to find the number that's in row n, column r, we're going to use that notation. Okay, so it's like a big set of parentheses. There's an n on the top, and there's an r on the bottom. And the way you pronounce it is n choose r. And the reason we pronounce it that way is because when we get into probability, this also happens to be like, let's say you had 10 objects and you want to choose 3 of them. That's actually the number of ways you can do that. Okay, if you had 10 different colored markers and I said, okay, pick 3. It's the number of ways you could pick 3. So what we have to remember though is when you use Pascal's triangle, you start with row 0, column 0. Don't start with row 1, column 1. If you do that, you're going to be off on everything. Okay. So any questions? We haven't really explained any of the math yet, just the symbol. Right, so let's actually, you know what? I'll show you Pascal's triangle written as binomials in a second. All right, so I'm just going to say that it ends up with that. If you want to find n choose r, that's the formula. You can definitely prove that. Off the top of my head, I don't remember how to prove it. I'm trying to see if that's even something your book would try and tackle. Your book gives you the formula, but they do not explain where it comes from. So we could look up where it comes from. I think I did once, but I can't remember off the top of my head. All right. So n choose r, it's n factorial over n minus r factorial, r factorial. You just need to know what row and what column you're looking for. Now, when we do these calculations, these numbers can get huge, but I'm going to show you a way to have that not happen. So, this is how you could write Pascal's triangle in the notation I'm showing you now. The number at the top would be 0, choose 0. Row 0, column 0. The next one. Row 1, column 0. Row 1, column 1.
This is weird.
It's weird?
Yeah.
Does it make sense?
Yeah, it's weird.
So we're just, instead of saying the actual number that's right here, I'm showing you a formula for how to find it. Right. So what would be in the next, what's going to go right in this spot? What row is this? Row 2, column what? 0. Row 2, column 0. What's the next one?
2.
Row 2, column 1. And the last one? Row 2, column 2. And if you wanted to actually figure out what the number is there, well, you can do it quick. 1, 1, 1, 1, 1, 2, 1. But later on, that gets harder to do. How about this one?
3, 0.
Yep. Row 3, column 0. Next one.
3, 1.
Row 3, column 1.
3, 2.
3, 2.
3,
3, 3. So now, if you wanted to know the number in, like, row 20, column 7, well, I've got a 20 and a 7. I just plug them into that formula, and I can tell you what the number is. And that's on page 605. I think they go down a couple more rows, but you get the idea. All right, so now let's look at the binomial theorem, but this time I'm going to write it with this notation for the coefficients. So your very first term is going to come from row n, column 0. What row? I don't know. It depends what power you're using. So pick that row, right in its column 0. And remember, this would be a to the m. That's your first one. Now, the next one, row n, column what? 1. And what's going to happen to the exponent on the a?
It's going to go 2.
Goes what?
Down.
How many? Down 1. So a to the n minus 1. And what's going to happen to the exponent on the b? It's going to start coming up by 1. So b to the n. Or b to the 1 in this case. All right. Now, how about the next one? Row n, column 2. Row n, column 2. What's going to be the exponent on the a this time?
A.
A to the n minus 2. It's going to go down another one. What's going to be the exponent on the b? Yeah, b squared. It's going up 1. And this pattern keeps going. Right? So the next one would be n choose 3. A to the n minus 3, b to the third. So it keeps going. And eventually, you're finally going to get to the term where the exponent on a has gone down so much, now it's just a to the first. Okay? That's going to be in your second to last column. So you get to your second to last column, a is to the first power. You get to your very last term, the a is gone. It's not there anymore. It's like a to the 0. So that's why the a is gone. Also, once you get to the end, your b has finally reached its biggest exponent. It's been going up 1 all this time. It finally reaches the biggest number, b to the n. And your coefficient of your last term is in row n, column n. You've reached the very edge of the right-hand edge of the triangle. Okay, so it's kind of a lot to think about with letters, but it's the same thing you've been doing. Exponents on the a go down by 1. Exponents on the b go up by 1. Find your coefficients using the formula. Okay, let's try to figure out this one. I'm asking for the number in row 6, column 4. Now, I think I can go back on the slides and we can look up the answer. So let's look up what we should get before we start. Row 6, column 4. Let's see. So I've got row 6. That's the last row, column 4. 0, 1, 2, 3, 4. So we should get 15. We'll see what happens. Okay, what's my formula? I'm just going to write that off to the side. What goes in the numerator?
N. Exclamation point.
N. Or N. Yeah, N. Right? Exciting. N factorial over
Parentheses n minus r factorial r factorial.
N minus R factorial R factorial. Okay, so N R. Let's fill it out. 6 factorial over N minus R. What's 6 minus 4? 2 factorial times 4 factorial. Now, what I would do is just expand this out, because anytime you do a problem like this with factorials, the answer is never a decimal. Think of Pascal's triangle. There's no decimals anywhere. So every number in the bottom should cancel out with every number in the top. So let's write out 6, 5, 4, 3, 2. 2 factorial is 2. 4 factorial is 4 times 3 times 2. 4, 3, 2. 4, 3, 2. Gone. 2 goes into 6. How many times? 3. And what's 3 times 5? 15. That's exactly what we're supposed to get. So I didn't even have to worry about 6 factorial, which is like 700 something. Most of it just canceled out, and the arithmetic became very easy to do. Let's try this one. 9 choose 5. What goes on the top?
9 factorial.
9 factorial. And on the bottom?
4 factorial.
9 minus 4 factorial.
No.
Yep, and minus R factorial. And then the second parenthesis? 5 factorial. Now, I can write it all out. 9 times 8 times 7 times 6 times 5. But what's basically going to cancel out in the 9 factorial? Everything from what down? If you cancel out the most you can right away. Everything from 5 down. So 9 times 8 times 7 times 6 times 5, 4, 3, 2. 5, 4, 3, 2. That's all going to cancel. So all you're left with is 4, 3, 2. Any question on that?
No.
Now reduce whatever you can, doesn't matter what order you reduce in. 4 goes into what number in the top? 8, how many times? 2. 3 goes into what number? 6, sure. How many times? 2. And 2 goes into 2, how many times? Once. So you're left with 9 times 2 times 7. So that's what, 9 times 2 is 18. 18 times 7. Let's see, 18 times 7, 126. So that would be the number in Pascal's triangle. That is in row 9, column 5. Also, if you had 9 people in a race and you wanted to know how many ways the top 5 people could finish, that would be 126 different ways that those 5 people could come in 1 through 5. Well, out of the 9 people, how many ways could they finish? How many in top 5 spots? Okay. Questions on that? All right. So now, I want to know the 12th term if I were to expand this whole thing out. Now, I'll tell you the way not to do this. Expand the whole thing out. That's going to be pretty awful. Only have to find one thing. So I'm going to go back to our patterns for a second. Just to remember something we said very early on. When you expand something to the nth power, you end up with n plus 1 terms. Okay, keep that in mind. We're expanding something to the 15th power. So how many terms am I going to get? 16. So what I'm going to do is, you don't have to do it this way, it just kind of helps me to keep track. I think I put 16, pretty sure I did. Now, because Pascal's triangle starts with row 0, column 0, we have to do kind of the same thing here. This is the first one, which I'm going to call the 0th. 2, 3, I can't write and count. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's really 16 terms. So they want to know the 12th term, okay? Starting with the 0th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me just make sure I counted right. 12. Find the, let me double check how they are doing that. Okay, yep. So basically, what they're looking for here is that they want to know in the 15th row in Pascal's triangle, what would be the 12th, the number in the 12th column. That's how you're going to get your coefficient. You know what? When they say they want, they say they want the 12th term, I'm pretty sure they mean the 12th term, the way they labeled it. That's what they want. Okay, I would be clear about that on the test, but when they say 12th term, that's what they're looking for. The 12th term labeled starting with 0. All right. So let's figure out what our exponent on x is going to be and what it's going to be on y. We start with x to what power? 15, and then the next one? 13, 12, 11, 10, 9, 8, ow. Had to move on me. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3. So it's going to have an x cubed. And now we know that the two exponents, x and y, have to add up to what number? 15. So I mean, you can count again if you want backwards, like 14, 13, 12. Or just know that they have to add up to 15. Okay, so we got that part. Any questions on that? All right, so that would work if we had this. You've got your x to a power, you've got your y to a power. But what number do we have with the x? Okay, so put it with the x. What number do we have with the y? 3. Okay, so put it with the y. And now all we have to do is figure out 15 choose 12. Let's see what that comes up to. Okay, so to figure it out, what goes on top? 15 exclamation point. And on the bottom? 3 factorial and 12 factorial. Okay, when you write out 15 factorial in the top and cancel it with the biggest thing in the bottom, what's left? Just 13, 14, 15. So 15, 14, 13. Everything from 12 down is going to cancel with 12 factorial. And now in the bottom, 3 factorial is 3 times 2 times 1. Okay. 3 goes into 15 how many times? 5. 2 goes into 14? 7. So I have 35 times 13. Okay, so 455 times, what's 2x cubed? This is the easy one. Next one gets a little bigger. 8x cubed. Now, the next one, 3y to the 12th. That's big. 3 to the 12th. Well, actually, I guess it's not that big.
That's big.
531,441. That's big? Okay. So now multiply together your coefficients, and that's going to tell you the final answer. So we know it's going to be an x cubed, y to the 12th, and it's going to be 455 times 8 times 531, 441. We should have gotten 1,934,445, 240. Yes, then we did it right. Copy.
Wait, where'd you get your numbers from?
Where did I get the numbers to multiply?
Oh, I'm just kidding.
Yeah, just those here, here, and here. So just to get that one term, that's definitely a little bit of work. That's why I would never ask you to expand out that whole thing. So that's the term they were looking for. Now, that's probably as big of a coefficient as I'd ever have you expand out. I mean, you just use your calculator, but it's probably not going to be that big on the test. Or if it does get that big, I'm just going to leave the answer as an exponent, like 3 to the 12th power. I'm not going to do it at all. Okay, so any question on that? All right. What if I was looking for the 6th term? Same problem. What would I circle, just to make sure we know what we'd be looking for? The 6th one, right? You always count, if they say to start with 0, 0, 1, 2, 3, 4, 5, 6. That's the 6th term. Just exactly the way it's labeled. And how would you write the notation for what you're looking for here? If you wanted to know the binomial coefficient. Yeah, it would be 15. It's always 15 in this problem. 15 choose 6. 2x to the what power? 9, yep. And then 3y to the 6th, yep. And we'd have to do out the 15, choose 6, see what you get. And then do 2 to the 9th times 3 to the 6th. That's how you can find a specific term when you have to expand out something that's a really big power. Any questions or any, just it is a little bit to kind of keep track of in your head. Just remember to start with 0. That's the key. Any question on that? Okay, so that's the binomial theorem. Okay, so homework tonight on 606. 1, 3 through 8, 11 to 15, 17 to 19, and 21 to 25. Definitely don't need a graphing calculator. You can do this all with a regular one. And don't forget, I will be after school today if anybody needs extra help. I'll be here. Just stop by. Also, if you still have a test to finish up from last week, we got to get that done. Progress reports come out tomorrow. Yep. Well, they close tomorrow. You probably won't get them till next week. They close tomorrow. So what that means is the grade you get on your progress report and the grade you get for the term, they're not really going to be that much different. We only have one more test, so whatever you have at progress reports, it's pretty much what you're going to have for the term.